Have any questions? Here we go. On central tendency. Anything give you grief? Here, I'll fire the homework sheet up here. Anything from in here give us agita, lower back pain.
It's just because I was kind of having a moment, and I know we discussed this before, but I couldn't remember.
Having a moment.
They were talking about the mean, for the geographical middle. What do we do with the two of them? Do we do the middle? I don't remember.
Oh, median?
Yes, sorry.
Median, no problem. When you have two, just find the thing between those two. So, if the two were, say, 14 and 14, it's 14. If it was 14 and 15, 14 and a half. If it was 30 and 60, it'd be 45. So whatever, just find create a middle point. If there are two middle points, create one between them.
Okay.
I think the way the texts usually say is average the middle two. But what you're basically doing is just forcing another point between them that really actually isn't there.
Okay.
And on small data sets, that can be a little bit misleading, but as the data sets get larger, they tend to smooth.
Okay.
Great question, yeah. Haley.
Okay.
That was Rachel, right?
Yes.
Yes, Rachel, good. Haley, go ahead.
So on E3,
E3, let's look at that one. Here we go.
I got the answer for the median, but I think I did it like the way long, hard way.
Oh.
Like I wrote down every.
Oh, that's okay. I just said try to do it strictly using the dot plot. I didn't mean, I didn't say you couldn't. I mean, what I'm trying to do here, you all have been studying central tendencies since you were like tiny. I mean, since you were little tiny. This is one of the first things that students learn once they learn how to add and divide, is how to average numbers. So yeah, totally. You could totally do the median by chopping or listing them all out.
Right.
I was just trying to get you to say, okay, there's a bunch of data there. Where's roughly the middle if you were to put them in order? So, you know, I would say like these would cancel-ish these. And if I took these leftovers here, and maybe some of these, it would cancel this, and then these would kind of cancel that, and then I'm down to like somewhere in here.
Okay.
So I would call the median somewhere around 4.5,
Right.
somewhere in that neighborhood. That's all I was after. I mean, a ballpark. I know you guys can do arithmetic. I know that, And I know if I asked you to, you could list all those data points out, you know, 0, 0, 0, 1, 1, 1.
Yeah.
But I'm trying to get you to get from a ballpark, balance for an average, eyeball for the median, tall bars for the mode kind of thing. Kind of like a working, on-the-fly way of measuring center.
Right.
But by all means, you can list them all out, do it that way. I got no problem with that, Haley. You can list out, you know, 3 zeros, 3 ones, however many twos, x times x, x times f, x times f, and then just divide by the sum of f. No problem with that whatsoever. But I'm trying to instill, because it's an idea that you've seen for years and years and years, rather than just rehashing it the same way you've done it, there's a new way of looking at it too, a more intuitive way, a more kind of gut way.
Right. Okay.
Cool? And by all means, don't feel bad about doing it the old school way.
Right. No,
I'm
I
not
mean,
trying to.
I did it that way, but then I wanted to know like how you kind of were
So,
wanting us
great
to-
question, fantastic question. Back to Rachel's question about the median. Okay, the median is, I have to kind of, the median, the way I do the median is essentially the way we would do it, like rigorously in class, like chop, chop. Chop a high, chop a low, chop a high, chop a low. Keep working yourself until you're in the middle. But, I mean, kind of doing it roughly, you say, okay, there's a bunch here that basically cancel a bunch here.
Yeah.
And then you just kind of work your way in until you're in that middle, assuming, of course, the data is in order.
Right.
So that's how I do the median. As far as the mean, I always treat this one as a balance. Where would I put my finger to balance this data? So you guys tell me. Here, I'm going to start on the left, and I'm going to keep going. You tell me roughly where my finger would have to be in order so that horizontal beam would stay horizontal. If I put it here, obviously it would go poof and fall that way. So you guys tell me. Where should I stop? Ish.
Ish.
Ish here? I would say the exact same thing. It appears to me, ballpark, that there's just the same amount of stuff over here as over here. Although some of you might say, you know, I think there's more stuff over there. That's okay. Where would your average be then, if you think there's a little more stuff over there?
Mine was 4 because I cut.
Oh, your average is over here 4 lanes, so you think there's more stuff over here, totally fine?
No, average is, mean is 5 actually. My mean is 5 because I.
Oh, so that's what I'm saying. So if you think there's a little bit more stuff over here than over here, you
And
would
actually
place your balance
I
over
counted
here.
all the spots and
That's
stuff.
fine. But I was saying,
But-
if you're ballparking it,
Okay.
you might just say, it's symmetric. There's 0 through 4 has the same amount of stuff as 5 through 9. So therefore, you stick your balance points right there.
So is it okay, for example, my answers are a little different from
Of course, because I did mine approximately.
Okay.
I ished mine. Yeah, totally. Yeah, what I'm looking for is people not to say that the average is 0 or 9.
Okay.
Now the modes appear to be 7, maybe 7 and 9, and maybe 2. Are there the same number of 2s as 7s?
No, it's just 7 and 9.
More, just 7 and 9. 7 and 9s, yeah. Although if someone said that they think the modes are 2, 8, 2, 7, 9, I wouldn't be upset with them. Because, I mean, I look at that really quickly and I look away and I see 3 spikes.
Yeah.
Of course, on an exam, I know you're worried about that, and I want to put your mind at ease about that. I would expect 7 and 9 as answers because they actually have the most number of dots. But if anybody put 2, 7, and 9, I wouldn't mark you wrong because at first look, 2 looks like a mode to me too. But I think we agreed in class to keep things simple. Let's just call the one with the most the mode. So that would be 7 and 9 in this case. Bimodal. Haley, does that make sense? It's a long-winded answer to your question, but I think it's a good one because it puts Elena's mind at ease too, because she may have gotten slightly different answers than I approximated. But that's going to happen a lot, unless you're actually getting down to the nitty-gritty number by number.
Okay.
But I want you to kind of get a feel for that. Rachel, I love what you said, the geographic middle. That was fantastic, you know, being able to look at the 3 different measures of center in their 3 kind of colloquial kind of gut ways. Balance for mean, geography for median, and just frequency for mode. Yeah, totally awesome. Anything else in here give you grief? Anything else? There wasn't much in the book, it looks like. The book is pretty much straightforward. Just, you know, here's a bunch of numbers. What's the average? What's this? What's this? I like the E questions down here just because you get into the stuff where it actually applies to you. Oh, I got the answers too. Yeah.
I didn't understand E4.
E4, this one here, assuming that loose data are, oh, that's up here.
Yeah.
Okay, so everybody, if you would, take a minute and read this paragraph right here. Luke, my good friend and yours, Lou Dobbs. It's a little bit old now, 08, but go ahead and take a look at that and read that. You can ignore this 8.3 trillion. I have no idea what he's talking about over there, honestly. But it's the 200 billion that I'm interested in analyzing and making sure if that makes sense. If that makes sense. So first of all, is he right? Is he right?
He is right.
He is right. Lena's saying yes. Good, good, good. Why is he right? Where did that number come from? And this is one of those interesting things about averages that sometimes gets used in the media. And he is. I mean, he's ishing. But he's ishing completely correctly, in my opinion. Okay, no matter what the feelings of Lou Dobbs are. So, how is he correct? How do we know he's correct up here? Go ahead, Lane, go ahead.
We know actually the formula, X
Let me
average
slide this over a little bit so we can see the board.
is, what is it, E, what is it?
Big sigma, which means sum,
X,
right?
yes, okay,
So any
X,
average.
Any average, yes, it's big sigma X.
And what does that mean, big sigma X?
It means that sum, the cumulative average.
You're summing all the data up. You're summing all the data up.
Divided by n.
Okay, good. So now usually, I'm going to pause just for a second, I'm going to come back to you, because I want to hear what you say. Usually, you're finding the average based on a bunch of data. Because if you have a bunch of data given to you, you can add them all up and then divide how many you've got into that sum, and out comes the average. But Elena, how is this a little bit different?
So the thing is, see, we have the average.
They told you,
So
he told
we
you
need-
the average.
Yes.
Average price of a house was $206,000.
So we have to figure out how to do some other things. So it's 206 is, and then sigma x, as far as I have understood, is 200 billion plus, or what, 8.3 trillion
What?
divided by.
Well, the 8.3 trillion, ignore that for a moment.
Oh, okay.
Because he's saying if we paid off all the houses and the debt that's incurred by those houses, we'd have 8.3 trillion left over. He's not even talking about that getting paid towards the houses.
Mhm. So we
What's
got
N
1,000.
in this
I mean,
case?
a million.
That's the million, right?
Yes, that's the
A
million.
million underwater houses. So here's your million.
Okay.
What he didn't give you in this whole little interesting thing is the summation of x. He's making a claim about it. He's claiming that it's $200 billion. Based on the average price of a house being about $200,000, and there being a million such houses that are underwater. This is the average price of an underwater house. A million of them. Based on those two values, do you agree with this 200 billion?
So we can actually find it.
We can, can't we?
Yes.
Now what Lou did, and I think this is logical, is he forgot the 6. and he called it 0 to make the math easier.
So
And then he multiplied this times this, or whoever wrote a script for him did. And then, so what you essentially end up doing is adding 6 zeros to this number. By multiplication, this is the beauty of the metric system, right? Multiply by 1,000,000, you multiply this by 10 to the 6th, adding 6 zeros to it, so you end up with the summation of x, we'll come back to that momentarily, is 200,000 times 1,000,000, so what's that going to be? And what is that? That's $200 billion, isn't it? There's $200 billion. Which represents what? What is that? The average was 206. Now notice I dropped the 6 off. The 6 would actually be here, but that's we can ignore that. We can ignore it. He's ignoring it, so we can issue it as well. What does that represent, friends?
1 million underwater houses.
Jordan, help me out.
Total amount of mortgage or money taken.
Yes. If you actually added up all 1 million of those houses' values, or mortgage values, I guess at that point, it would sum up to $200 billion. We don't know how much each individual house costs. One house may have $1 mortgaged on it. One house may have 1.5 million mortgaged on it. One house may have 300,000 mortgaged on it. One house may have $25,000 mortgaged on it. We lose that. But Lou doesn't care about that. He doesn't want to make fun of people for mortgaging too much or credit people for mortgaging too little. What he wants to say is, this is how much all of those $1 million mortgaged underwater houses are worth from a mortgage point of view. And his point is, for $200 billion, that's a fraction of what is actually in the national debt. We could actually have paid that off, give them some kind of a penalty through whatever agency does that, and then maybe avoided the huge explosion that happened during the boom and the bust. I have no idea if that's correct, and I don't understand economics that well, but that's what his math is correct. As far as that $200 billion, it totally pans out here.
8.3 million doesn't play any role.
A trillion. Yeah, no, because what he was saying, Elena, is, I'm assuming the 8.3 trillion was part of the, no, it wasn't the bailout. The bailout wasn't that much, it was in the billions. It's some kind of debt measure. What he's saying is trillions versus billions, it's 1,000 times different. So what he's saying is, this is basically 0.2 trillion, right? Exactly, right? $0.2 trillion. They have an additional 8.3 trillion. So somewhere out there was $8.5 trillion money going towards something. He's saying this is a fractional part of it. So we should have headed off the bubble and the boom and the bust by buying up these toxic assets and then dealing with them kind of in a more sequential way. Whether he's right or wrong, I have no idea. All I was picking on was, is the number he used correct? And it is. He's totally in the ballpark. Assuming what? Assuming what? Oh, very good. I wasn't thinking about that, Haley. Yes, there is a margin of error because I'm sure they haven't counted each individual house. Although they could. With the correct kind of agency interaction, they could. I was thinking more like, assuming this is actually the average mortgage value in 08, and there actually were roughly a million of them. Assuming a million, assuming that's the correct average value, then that's how much they're all worth taken together. This happens all the time. I remember saying to my friend Matt Kangelman years ago, I went for a mountain bike ride, and we were moving pretty quickly. We averaged 12 miles an hour for 4 hours. And he said, yeah, we're out there for 12 miles. We averaged 12 for over 4 hours. I was like, wow, you went 48 miles? I'm like, no, we didn't go 48 miles. And that's when I realized we did a lot of bow, 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 then stop, and then sit there. Now, we weren't actually riding for all 4 hours. We did average 12 miles an hour in the time we were riding. But what he did really quickly was, oh, you averaged 12 miles an hour for 4 hours. 4 times 12 is 48. You must have covered 48 miles. I was like, oh, well, I guess if we were moving the entire time, we would have. I got to use that recently. when I looked at my little My Tracks going up and over Mackenzie Pass a couple times. And you can actually reverse engineer how many miles something is by knowing your average speed and how long you were out. Because the units, the nice thing about average is there's a unit attached that unfortunately gets lost. It doesn't get lost here. Average is in dollars. Number of houses doesn't have a unit. So this guy has to be in dollars as well. And when you add up all those individual house prices, you add a bunch of dollars, and that's how much they all worth. So that's a cool use of an average, where you're getting the sum total. As I said, you don't know how much each house costs. You lose that. You lose the house, the cheap house, the expensive house. You don't know what the median house cost is. You have no idea. There could be a few very expensive houses in here that are skewing the average up, or some very cheap ones that are skewing it down. You don't know that. But you do know, assuming these numbers are correct, that's where his $200 billion came from. I think it's a neat use of average, kind of in a sideways way. And pay attention, you'll hear that in the news very often, very often. Cool, ish, fair, good. Anything else in there give you grief?
My actually concern, well, I didn't know how to do it. The last one, 7.
7.
Yeah, I mean.
Which one is 7? Let's look at 7.
Yeah.
Now it's time to plan for winter term 2010. The student would like to have a GPA of 3.6. He'll be taking 12 credits. Is it possible? Why or why not? Tell me more, Elena. What gave you grief on this one?
So, that's 12, and then you said 12, and then question mark.
Mm-hmm.
And then I didn't know how you came actually to this 3.89.
Well, let's figure it out then, shall we?
Thank you.
So we're going to have to know, what kind of average is this going to be since it's a GPA? What kind of average is it going to be, my friends?
B plus-ish.
Say that again?
It's like B plus.
Oh, I'm sorry. I wasn't thinking that specific. In general, what kind, when you're talking about calculating your GPA, what kind of an average are you calculating?
An accumulative?
Good, cumulative, which makes it weighted. You have to weight it for your credits. You can't just add a bunch of numbers up and divide by how many there are. And for example, numbers being how you did in each class, you can't add a bunch of A's, B's, C's, and D's and divide them. Because some of those A's were worth more than others, some of those B's might be worth more than others. Let's slide this bad boy over here. Still got battery, yep. Okay. So, I'm going to assume we got through E6. So, his cumulative, let me make sure I got this right. Okay, so the answer to E6, you must have gotten through E6?
Yep.
So what's his cumulative?
3.55.
This is up to
GPA cumulative, yes.
fall 2009, right?
Mm-hmm.
Okay, and that, I'm sorry, Lena, what was that?
3.55.
3.65?
50.
55, okay. He's got a 3.55 GPA, or she, he, whoever, this person. 3.55 GPA up to and including fall 2009, and how many credits does that account for? 58 plus his fall 2009, which was up
69.
there. 69?
Yes.
Yeah, 11 more,
Plus
right?
11.
So that's 69 credits. Cool so far? That's what we got so far. Now, this student wants to have a GPA of 3.6, okay, after winter term 2010. How many credits is the student going to have in winter term 2010? 12 credits. Believe it or not, this is one step past Lou Dobbs' question, believe it or not. Believe it or not, it's one step past Lou Dobbs. It's the same idea as Lou, in that you know what the desired average is already. But what you don't know is how the student's going to do in each of the classes. We'll come back to that when you actually see the data laid out for you. Now, how do we know this is going to be a weighted average? How do we know this has to be a weighted average, other than the fact that 5 minutes ago we guys said it had to be? What's present up here that kind of shows you it has to be a weighted average?
Decimal. I mean, it's decimals percent. It's not whole numbers.
Well, that could or could not actually. That would be indecisive, because in fact he could have a 3.6. Oh, you're saying if no decimals at all. So he could have a 3 GPA, 3.00, with 58 credits, and want a 4.0 by taking 12 more.
Right.
That would be easy to answer that question if you could pull that off. But nonetheless, decimals aren't a make or break deal as far as the weighting goes. What is the make or break deal? Think back to class last week. What made it weights back then?
Like say a sports class or
It-
an activities class
How much the credits?
Gen, right?
Credits, yeah.
Credits, right? Is Jen, right?
Yes.
Okay, good. It's the credits. It's the number of credits per class. So these guys over here, these credits. Now, what I didn't tell you in E7 was which classes the student was going to take. We didn't know weightlifting, U.S. history, economics, statistics. We didn't know what classes, but we know he's going, or she is going to take 12 of them. And you're about to see, it doesn't matter how many, or excuse me, how many each. You could take 12 HHP classes at 1 credit each, versus 3 4-credit classes at 4 credits each to equal 12 credits. And you're about to see why it doesn't matter. What matters is just the sum total of 12 credits. So, just like you did up here, we're going to analyze the cumulative GPA in a chart. And the chart's only going to have two elements to it. We're going to have, I'm going to label it over here on the left side. It's not going to be part of the computation, but it'll help us kind of keep track of what we're looking at. So here we'll do up to and including fall 2009. We'll do that there. Put a little line here. And then we'll do winter 2010. So that's just to keep us kind of straight as we're slugging through the math. Okay. Remember the way we set up the weighted averages in class? We used some variables. Okay. We used X's and F's. X's and F's. Remind me what each of those was. Remember what is X? When you see X in this class, David?
Data.
Awesome. That's data. That's what you're actually manipulating. You're actually manipulating that data. Okay. So what is the data? What are we interested in this problem? The GPA, Haley. We're interested in the GPA. So up to and including fall 2009, we know this student had a GPA of 3.55 over 58 credits. So essentially, you have to count that 3.55 58 times for those credits. We'll come back to that momentarily, okay? Because that might not seem sensible. Because some of you might say, what the hell? He didn't have a 3.55 58 times. He had a 3.55 average over all these terms. Hold tight. There's a reason that doesn't matter. There's a reason that doesn't matter, if that's upsetting you. Now, GPA winter 2010. We don't know that, do we? No. We don't know that. I think that's where the question mark is set.
He wants 3.6, but
we want a 3.6, but not necessarily winter 2010. We want to know what he has to do in winter 2010 to get a 3.6. Love that, by the way.
Wait, isn't it 69 credits?
Totally. But up till fall 2009, he's only taking 58. 69, Haley? Thank you. It was 69. Thank you, my friend. I should never, ever second guess a student with arithmetic. No, because you guys are right like 99% of the time. For some reason, I was looking up there and seeing 58, but then forgetting to say not including fall 2000. My friend. You even told me it was 69. That's why I wrote it right here and then promptly forgot it immediately after. Thank you, my friend. So, 69 total credits up till that point. Good. How many credits in winter 2010?
12.
12. Now, here's the deal. Put this screen down a little bit more. I want to add one more column down here if it's okay with you guys. Because we have to get that 3.6 in there somewhere, don't we? That 3.6 is important. That's going to be the overall, if you will, his over or her overall GPA, including all of these terms and winter 2010. We want that, we desire that to be 3.6. I know this stupid desk is in the way.
Right.
So we know the overall GPA is 3.6. Over how many credits? So if I can do this.
81.
Is it 81?
80, yeah.
Okay, sometimes I can add.
81.
There. Over 81 credits. Fair enough.
So now we do XF.
Good, exactly. We still have to use the same idea we did in class with the X's and the F's and the multiplication. And that's going to tell us something. So, for example, I'm going to take this away if it's okay with you guys. I think we've got room to get rid of that now. So, we need an extra column. Let me do that in a different color too. The way it stands out. So that beautiful X times F column that we did earlier. When you get 3.55 times 69, what do we end up getting, friends? 240 something?
244.95.
244.95.
Yeah.
Let's pause right now and ask ourselves, what is that? What did you just do? I mean, besides multiplication. What's the unit on this? What's the unit on this? What do you think? And this might be tricky for you to verbalize because it would require you to know what the units on a GPA are. So what do you think? What is that ish? Go ahead, David.
I'm just thinking it has something to do with the value.
It is. It's the value of all the classes that you took, up to and including fall 2009. Remember how each class,
Quality.
4 points for an A, 3 points for a B, 2 quality points you just said. That's the term I think is used, right? So 16 would be the number of quality points if you got an A in a 4-credit class. 12 would be the number of quality points if you got a B in a 4-credit class or an A in a 3-credit class. So essentially, what this is telling you is how many quality points you have over 69 credits. Does it tell you how many A's and B's and C's and D's and F's you got? No. Just like this number, does it tell you how many mortgages had $1,000 versus $1 million versus $5 million? All you know is that's the sum total of the mortgages. That's the sum total of your quality points. That's the sum total of your quality points. Is that fair?
Yep.
Is that fair? Good. Very good. I love that term, quality points. I believe that's even the one that's used. I'm remembering back my
I know
university
quality's
days.
right, I'm not sure whether it's points or credit.
I think it is because it's called a grade point average. So essentially, it's either a grade point or a quality point, and you're averaging it. But by multiplying by n, essentially, you're removing the average, and it's just becoming the grade points. Beautiful. 12 times question mark? That's just 12 times question mark.
Okay.
You're going to be solving for that. That'll tell you how many quality points you have to get in winter 2010 in order to get the number of quality points you need to average a 3.6, which would be how many, friends?
291.6.